We are going to take a look at 3 inequality word problems. The only difference between these problems and the word problems from the past section is that these problems are going to include words like at most, at least, no more than, between, all words that we associate with inequalities. So let's take a look at this first one. Amy wants to fence in a garden whose length is 2 more than twice its width. What is the greatest width of her garden can be if she has at most 70 meters of fencing? This should register to you as a geometry problem, so let's draw it out here. We want to fence in a garden whose length is 2 more than twice its width. So if we call the width W, the length is 2 more than twice its width. So that would be 2 more would be a plus 2. Twice its width would be 2W. So 2 more than twice its width. It says, what is the greatest width? So this is our question right here. What is the greatest width her garden can be if she has at most 70 meters of fencing? This 70 meters of fencing applies to what? It applies to the perimeter. So in order to write an equation here, we would have to find the perimeter of our garden. So we would have W plus 2W plus 2 plus 2W plus 2 and our 70. If we have at most 70 meters, can our perimeter be greater than the 70 meters, less than the 70 meters, greater than or equal to the 70, or less than or equal to the 70? Well, if this is how much material we have, our perimeter has to be less than, but could be equal to, that 70, since that's the quantity of fencing that we have. Once you combine like terms and solve this down, I got W is less than or equal to 11. Now, just like before, we got to go back and make sure we answer the question. What is the greatest width that she can have? Well, if width, which is what our W stands for, is less than or equal to 11, then the greatest width is 11 meters. You need to answer the question. In this case, it might take more of a sentence rather than a singular number. The greatest width is 11 meters. Let's take a look at the second one. The student government can sell a total of 400 tickets to a basketball game. An adult ticket costs $3 and a student ticket costs $2. What is the minimum number of adult tickets that must be sold if the student government wants to collect at least $1,100? So again, you're seeing these inequality words, at least $1,100. Now, this problem is one of those problems where we're going to have to take some notes. We have the adults plus the students, and let's see here, our total value is $1,100, but if I want at least $1,100, then I would want greater than or equal to $1,100. Just like if you said, okay, I will sell this item, I want at least 20 bucks for it. You will take greater than $20, but you'll also take $20. Now let's continue on looking for information about the adults. The adults says that their ticket costs were $3 each. So remember, since we're dealing with a money total, this is the cost times how many. Plus our students, which have a cost of $2, so it's the cost times how many, is greater than or equal to our $1,100. Now we need to find some information about how many of each ticket were sold, and that comes in the first sentence. The student government can sell a total of 400 tickets, so maybe that's how many seats are in their particular gym. So if we can sell a total of 400, to write the amount of each adult and student, I want you to think about it this way. If we can sell a total of 400 and we sell 100 adult, how many student tickets would we sell? 300, because you would subtract the number of adult tickets you sold from the total to get the number of student tickets. Since we don't know how many adult tickets were sold, we're going to do it algebraically. adults would be X, and the students would be the 400, the total, minus that number of adult tickets. So it would be 400 minus the X. You can go ahead and solve that down. I got X is greater than or equal to 300. So now let's go back and make sure we answer the question. What is the minimum number of adult tickets that must be sold? So the minimum number of adult tickets. If we look back, X represented the adult tickets, how many were sold. And if X has to be greater than or equal to 300, then the minimum number of adult tickets that need to be sold is 300. Again, a lot of these inequality questions will require your answer to be a sentence. The third one here, Cindy has scores of 72, 82, 83, and 89 on her biology test. Use a compound inequality to find the range of scores she can make on her final exam to receive a C in the course. The final exam counts as 2 tests, and a C is received if the final course average is from 77 to 84. That key word, average. How do you find average? Well, you add everything together and divide by how many things there are. So let's see. I have 1, 2, 3, 4 tests plus the final, right? But the final counts as 2 tests. So when we think about finding average here, we have our 4 tests plus the final counts as 2, means that altogether we're going to have 6 total tests. The 72 plus the 82 plus the 83 plus the 89 plus the final exam, which counts twice. So that's how you find average. What does our average have to be? Well, it needs to be between a 77 to an 84. If your score needs to fall within that range, let's set up a between inequality. 77 is the smallest number that my average can be, and 84 is the largest number that my average could be. As you go to solve this one down, I suggest multiplying by 6 first, because that'll give you the inequality 462 is less than or equal to 326 plus 2x, which is less than or equal to 504, which makes it a little bit easier to solve down and get 68 is less than or equal to x, which is less than or equal to 89. So again, let's make sure we answer the question. The question says, find the range of scores she can make on her final exam. So I would say that she needs to score anything between, since we have our between statement, a 68 through 89%.